Ready?
I worked with Charles this semester on his theory for wave modeling asset prices, kind of his peaks of physical waves. And he had a thought that maybe crashes in certain assets occur like physical waves, how it builds up momentum and maybe follows principles of physics, and how when you see in like the wave of an ocean, how it kind of peaks off at the end and curls. It's not one smooth a wave, but it actually does this really rapid descent. So he had a thought about that, and then he started doing a little bit of reading, and we worked on the Hurst exponent. But I just wanted to start off with where I was before this semester started. I had pretty much no idea what really entailed financial engineering or quantitative finance. I didn't really understand. I knew that there was a lot of coding involved, but I didn't really know what they used as their starting point. What was the thing that made financial engineers stand out and really valuable to their companies or to themselves for whatever it is that they created. And with that being said, I had very little to no coding experience at all. I've taken two very simple MATLAB courses, which is an engineering language. And it really is not very applicable to financial engineering in any way. So as far as my coding experience, I knew that that was going to be a big hurdle coming into this project. And also my goal was kind of to help Charles create a profitable tool with this that he could use for anything necessary, but also it would be something that I could say that I helped with and learned a ton about, and tried to find out how it is that tools are created that are profitable, that do stand out. And I'll talk about that in just a second. But to introduce the Hurst exponent, they did something with this complex mathematics I'll briefly touch on in a little bit, where they decided to try to take a pairs trading strategy, which involves things like the co-movement of two stocks at once that typically would move together. The idea being that if they ever separated at one point, that they would tend to come back together. So the idea of trading on a pair like that, he wanted to combine this paper, combined that with the mathematics of the Hurst exponent. The Hurst exponent was used in the pairs trade. Like I said that already. The empirical application versus classical strategies is what was analyzed in this paper. So they took this pairs trading strategy with the Hurst exponent and compared it to two other methods. And what they did is they took pairs in the S&P 500. Or no, the Dow Jones, and they took two stocks from it at once, and they treated them as a co-movement, and they applied the Hurst method, the correlation method, and the distance method, and graphed the returns over 15 years here. And so this is with 10 different pairs, and then with 25 different pairs, you see actually an even larger distance between the Hurst performance and the other methods. And so obviously this is a big eye catcher. If you're going to read a research paper and it just says that returns are way higher than in other methods, you're going to kind of question why. And this is something that was very kind of overwhelming to me at the start to see all this mathematics, and it's something that you need to have a decent understanding of code to be able to do. So I knew that there was a lot set out for me at the beginning of the semester, and Charles was very helpful with that. So for him personally, he wanted to replicate this paper, create the code for it, back test it. And that was obviously a huge project to set out from the start, because you have some very, very smart people who wrote this paper. And he tried to build this code from the ground up and be able to spit out something that had the same returns from the S&P 500 and show that show the same returns that they got that were back tested on the same data. And so if we could show the returns that came from the paper that were used on the same data over the same period of time, we could say that we've successfully replicated the paper. And for me personally, I wanted to learn more about quantitative finance, but really just get a better idea for what financial trading strategies really entail. And then obviously to improve my coding. And you can see here on the right side, this is just a very basic project called the Magic 8 Ball that I learned in this program called Codecademy, where they do a great job teaching. They give you a little prompt on the left, little steps, and you can have little hints if you need them or whatever. You put your code in the middle and it spits it out on the right. It's a great learning experience. And it made it very easy to digest some hard concepts that were obviously thrown into the muck of that detailed code that we had to analyze throughout the semester. So that being said, when we
did you read that book?
I read a couple chapters. I didn't read the whole thing. I'm not
This
that
was, I
productive
will
with the
tell you,
reading.
this was one of the most incredible books I've ever written. That book opened me up, and in fact, I used it a lot in my course, if you recall.
Yeah, I do
Because on
remember
one
you
hand, you
quoting it a
got this
couple times.
guy, you got Mandelbrot, and then on the other half, you have all the other guys. You got
Yeah.
Markowitz and blah blah blah.
Mhm.
Tug of war here.
Yeah, no, and that was absolutely something that stood out to me. I love to talk about math. Personally, I have a little bit of a nerdy interest in the mathematics of it all, but but I loved what they talked about with turbulence and
Yep.
how even today physicists don't really fully you can't fully predict turbulence, and that's part of the reason that we still don't have planes that are just perfectly smooth the whole way and things like that, and how financial markets act like that. So that was pretty cool. But we had some problem with data collection. I got to learn about the Bloomberg system terminals and all that. It has a user interface that's left a little bit to be desired, but its functionality is great. And we were able to get a ton of data that we needed. One of the hard parts, though, was getting minute by minute data. So it was very easy to get in contact with people that could help us get towards that. But to actually find minute by minute data for 15 years for all of the stocks, it was just a mess to start with. So there were things that we had to really we just had to learn how to problem solve pretty much. And then obviously with the paper replication itself, you're writing this complex code and it has to do a lot of things at the same time. And a million things can go wrong. If you run the code and it doesn't do it all at once, you kind of have to go through everything and kind of find out where you went wrong. So obtaining the same returns was a problem, and then fixing the problems was fixing bugs was a whole nother issue that was constantly coming up, and it was actually much more of a time consumer than the actual idea forming and writing itself. So today, Charles and I have something that we can consider very, very close to the actual returns based on the number of pairs with this Hurst exponent trading strategy. I'm happy to say that I have a little bit better coding experience, especially much better than I did at the beginning of the semester. And next semester, we want to try to tie it into his theory that he had originally and see if there's any additions we can make with wave mathematics that could possibly benefit or improve the paper itself. And that's where I hope to be able to contribute a little bit if I can, wrap my head around a little bit more of the complex mathematics. So that being said, a couple lessons learned that I thought were big key takeaways here. Programmers aren't novelists. They don't write these long things that are all just kind of ideas that come to their head. They write their code and they're problem solving. So they're constantly putting out fires. And it's just a million things that could go wrong at once. And you could never tell a programmer could never tell you what it is they're going to be working on tomorrow, at least from what I've seen with Charles and myself, because it's significantly more about, going to the internet, finding out what a little chunk of code is that you can add or how you can you fix a certain bug and those kinds of things. And then just kind of a little tidbit I've heard from a couple different professors, but I thought was funny reading this book about turbulence is that forecasts are always wrong. It's just a matter of how much. In theory, obviously, you could be on the dot here and there, but the real point is seeing how accurate your forecasts will be, identifying the patterns in the mess as it is, and kind of seeing the trends in the turbulence. And then really the most important lesson from all this is that mathematics is kind of the key. The people who stand out tend to be the ones who have the deep understanding of mathematics, that have some kinds of revelations that they can apply with obviously an outstanding background in coding and things like that. So that definitely seemed to be the outstanding sort of summary.
Just remember one thing: mathematics are there.
Mm-hmm.
They are just waiting to be discovered.
That's it. That's the one. Yeah.
It's out there. So you're not gonna. You just to be smart enough. I mean, look at